Hey guys, BBI here. I want to stop and say thanks for tuning in and checking out whatever the video is about that's about ready to come up next. If you could take a minute and hit subscribe, I'd greatly appreciate it. And if you enjoy what you've seen here, make sure to hit the like button. We'd greatly appreciate your support. Anyhow guys, all that aside, let's get on with the show. Phone's ringing already. I'll have to call you back in Massachusetts. Well, Mr. Dave, let's take a look at your notes, man. So this is take 2 on this thing, by the way. Now, I actually bothered to hit record. I thought I shot this video last night, but apparently I didn't hit the record button or it didn't get transferred over to the computer or something. So, Dave says to me, amp is low on power, only 200 watts. When I unkey the mic, I lose half of my receive. If I key up and unkey real quick, the receive comes back. It only does this when the amp is being used. Slow the amp fan. It is too loud when I am talking. Okay, Dave, let's walk through it. Now, unfortunately, since I've done this repair, the parts that I'd normally pull out and I'd show everybody, this is what happened, this is what went bad, these are the parts that went bad, and they've already been pitched. So I did a couple things, Dave. Now, we talked on the phone yesterday, and I couldn't remember if this had sideband in it or not. It does, okay? This is your bias right here. So bias is a very elaborate term that everybody uses to describe the device, whatever it is, either it be a transistor, a tube, a MOSFET, whatever, to control the device's ability to turn itself on and off, and its ability of how much you're turning the device on and off, or at what percentage you're turning the device on and off. Bias is usually measured with the amount of amp draw that the circuit that you're implying either the positive control voltage or the negative cutoff voltage to the device for. You can measure that. It's normally gauged in milliamps, but quick references, you can do it with a voltage if you know what you're looking for. This thing is perfect. It's set up for sideband, so you're not going to have any more problems with that. The things that we talked about on the phone were, it's real simple. The output tuning capacitor here went bad, and the one that was in there was only a little 500 volt deal. So I went ahead and I put a 5 kVA there. Well, they claim that's 5 kVA. I think of it more like a 1000 volt or maybe a 1500 volt cap. You're going to have a hard time getting that thing hot. The caps will get hot from being in circuit and being overloaded with too much voltage going by them. And they'll break down when they get hot. They'll start losing their ability to hold their reference to ground, or their ability to be a capacitor, just from heat degradation. So I went ahead and upgraded your cap. I brought your power output back up. I did the power wire upgrade on the inside of this thing, which helped it just a couple watts. And then the other thing is that the receive issue that you were having was the relay was sticking. Well, these are sealed relays, so I just went ahead and I put a whole brand new relay in there. There's no point in trying to do anything to refurb the relay or anything. I just put a brand new relay in there and we're done with it. So now you said that you do like 35 watts or so into this thing. We're going to use the 2950. We're going to use the 5 watt slug between the 2950 and the amplifier to represent input tune. Shoot 1000 watt slug in PEP, 1000 watt slug in average, 5 watt slug in reverse back from the bird, 10,000 watt dummy load. Okay, so the first thing that we're going to show you is the radio's ability to talk through the amplifier. Because you got to remember, the RF has got to come through the coax connector, and there's a whole bunch of other shit that's attached to this circuit. Let's get this down in frame. There's a whole bunch of other shit that's attached to the circuit that makes it work. There's a capacitor here, and the reason we're doing that is the capacitor's here because the way that xforce does their biasing circuit, I don't like doing it like this. I like having the bias circuit separate, but through the sheer ease of being able to add a couple chokes and a few caps, you can use one relay to do the job of 2 different functions. I like to split the 2 up. I've seen it fail, this circuit fail twice, to where it put positive voltage on this coax lead and it fries the radio. But you got to think, out of 10 trillion amplifiers xforce has built, and the several thousand that I've repaired, 3,000 or 4,000 boxes I've repaired at this point, not of just xforce, but of everybody's. I've only seen the circuit fail maybe twice. But still, because I've seen it once, I want to design my circuit to where there's another separate relay that controls the 12-volt swap. Now you can use the capacitor. Remember, a capacitor's primary job is to block DC current. But the DC current and voltage, the AC current and voltage can pass by. Well, RF is AC, so therefore it can pass right through the capacitor. Hence the reason the RF comes in, goes through this capacitor, and then now we're introducing the 12-volt signal that runs the bias. Okay? So the RF is coming in, so now you've summed the AC and DC signals together. The AC signal of the RF and the DC signal of the voltage that is going to be come over here, and it goes to your load cell, otherwise your resistor, then your diode that creates your reference to ground, otherwise dictating how much actual voltage and current is going to be present on the other side of this load resistor. Okay? Hence the reason there's this extra choke. So the actual 12 volt is off until you flip the switch on. When the switch comes on, you can see over here where it attaches to the relay, the 12 volt current shows up, and then to help isolate it and choke it from backfeeding through the rest of the circuit, you have these coils. Now what the coil does is you're creating an unbalanced circuit to where the RF doesn't want to travel that way. So instead of keeping that's how you keep the RF on this side of the relay, and it's not trying to backfeed into the positive circuit of the amplifier. So you're creating a non-resonant pathway. So that's how you split the RF and the DC voltage. Here they're summed. This is how you separate them apart. So the relay, when it switches, it takes the 12 volt DC through the same contact point that the RF is on, switches it, and the RF comes out, goes around and comes down on this coax and goes around to the input. But because the RF, as soon as it switches to the on position, can't travel back up this coil, now we're charging this circuit with 12 volts. So when the relay switches and goes into the latched position, the DC current can run backwards, DC current and voltage can run backwards across the circuit, and now we have another isolation choke here. This keeps the AC and the DC separated. So the AC goes this direction into the relay, and the DC current comes out and runs the bias. So when the relay unlatches, this circuit now becomes isolated from the 12 volts. This circuit stays hot, but because there's this capacitor here, there's no place for the DC current to go because it stays on the other side of the capacitor, because the capacitor basically acts as a block to the DC voltage and current. That's how the bias circuit works in this, David. So you've got your bias circuit in here, so you're set up for sideband. We replaced your relay, replaced the cap, the thing came right back up in output power. Here's our drive. About 20 whole peak watts, right? Bird average. About 5, maybe 6 bird. Run this in the high position. Do yourself a favor. Leave that in high. Okay. 20 watts of drive. There's your 500 peak watts output. About 180 watts average. Input tune. It's perfectly flat. Now, before I get myself sidetracked again, we're going to shut the amplifier off. That's our pass-through tune. Otherwise, the RF's ability to come in, come through the coax connector, go through all of these caps with all this other shit attached to the same circuit, then come up and go through the preamp, come back down, go through that coax or through that connector on the second relay, back to the first relay, and then goes back out and comes out and goes through and then goes down to the dummy load. Basically, no resistance to the RF, the circuit's in tune. Okay, next thing. Now this is an unregulated supply, hence the reason that we're getting such great performance with such little amount of drive. This thing is sitting here floating at about 18 volts or so, give or take, and then when it comes into operation or underneath load, that voltage drops and comes down to about 16 volts or so. Now we're going to whack this with the Connex 4400. okay, which is about 120 watts of drive. Got ahead of myself. Let me shut the amp down. Now I know, David, this isn't the way you're going to run it, but I've got to show it anyhow for test purposes. There's our 600 watts. About 210 bird. Okay. That's fully chooched out. We're not going to get any more performance out of it than that. 600 watts out of a 2-pill peak power. Those are good numbers. So now we're going to go in reverse. In power, that is. We're going to hook up the little derail radio. Little Cobra 29 that's up here. Let's turn on the blower motor. You can hear it starting. It just spins up. Eventually it'll get going crazy fast. Let me show you what we're doing for drive here. Same 20 watts peak, right? Check out what this does. It's like pouring gasoline on a fire. Now remember, with the 2950, we could barely get about 110, 120 watts average. About 270, or about, no, pardon me, about 170 bird. And we're right back at about 450 peak watts. Now let's talk about the fan. Listen. I love that radio. Let's talk about the fan. I can't technically slow the fan down. What I can do, David, is I can change the fan to where it's slower. The problem is that if we don't have the same velocity fan in there, shit's going to get overly hot in here and it's going to break down. The main thing that causes the noise is this grill face. The air cavitating around each one of these slots causes turbulence on the edge of the fan blades. So because the air can't run laminately into the hole or into the intake space, it's all turbulent on the other side. So there's low and high pressures. You're going to have a low pressure right underneath the ridge of the fin, and then in between the gaps you're going to have a high pressure. Your fan blade's sitting right on the side of that, so it's having to chop through that turbulence, and that's what makes this noise. Now it gets a little bit better when we put the cabinet on amp. But you're still saying this is too loud. So the only other option that I've got for you, and it doesn't look very professional when I do this, is what I do is I cut out these center two fins right about in here. I take my 120 millimeter green lead die and I punch this out and make it perfectly round. There'll be a missed lip here, and a couple of these edges on this grill mark are going to be lipped. So I'm explaining this to you, David, because I want you to be able to call me on the phone and tell me, now that I've explained all this to you, do you want to have kind of a grizzly barred cutout thing? I mean, it's going to be perfectly round because I'm going to use an actual green lead punch, but it's not going to be smooth on the edges. Then we put a regular fan guard. That'll help a bunch on the noise. Or do you just simply want to build like a guard? Like what some guys will do is they'll take some cardboard and some duct tape and they'll make it so that, you know, it hangs over the edge of each side of the cabinet and it's louvered on the front, and then the guard goes back this direction, hanging over the top of the cabinet so that fresh air can flow in this way, but it shoots all the noise in one direction and keeps it away from your microphone. You let me know whatever you want to do before this thing leaves here. I will make sure it happens. Either I can put a slower fan in it, but then you got to be worried about everything overheating and possibly breaking down, or I can punch a hole in the lid, get rid of these grills, make more air move through this thing, and it'll be a little bit quieter. You let me know what you want to do. I'm not going to make that decision for you. Gentlemen, my name is BBI, and hopefully school has been entertaining for you all today. I don't know how I got off on that tangent talking about the bias circuit, but we just went over it. That's it. That's all I've got. I got to get on to the next one. Appreciate y'all tuning in. My name is BBI, and without a shadow of a doubt, I am the biggest mud duck in Idaho. Period. If you've enjoyed what you've seen, do me a favor, click subscribe. Give me a like. There's a lot of content for everybody to watch. That's the only way I can gauge the support for this. And guys, thank you for all of the projects I've got showing up here on a daily basis. Please keep them coming. because I am no longer taking on any new builds at this time. I'm solely working on repairs. Guys, I gotta get on to the next one. David, give me a call. I'll see ya. Bump, bump.